All right, in this question, we have to express this term and this term. So this is an R method identity question. The first thing we need to do is apply the compound angle identities of cos and get a single expression in terms of sine plus a single expression in terms of cos so that we can apply our method identity on it. Okay, so for part A, we have 3 sine x plus 2 square root of 2. And in the bracket, we'll write cos x cos 1 by 4 pi minus sine x sine 1 by 4 pi. So 3 sine x plus what is cos 1 by 4 pi? Make sure the calculator is in radians. Okay, this is square root of 2 upon 2. And sine 1 by 4 pi is also square root of 2 upon 2. So now we will expand this. We get 2 under root 2 times under root 2 upon 2. That's just 2. So we get plus 2 cos x. And similarly, we get minus 2 sine x. This gives us sine x plus 2 cos x. Now we can apply our method identity on it. We know that A is 1 and B is 2. So R is square root of A square plus B square. So 1 square plus 2 square would be under root 5. And alpha is found by taking tan inverse of B upon A. So tan inverse of 2 upon 1 shift tan 2, which gives 1.107148, but we need the answer in 3dp, so 1.107. Okay, now we will, okay, no, part A is done. In part B, I'm going to first write R and alpha in the form of this. So R came out to be under root 5 and sine x plus alpha came out to be 1.107. Now we're going to look at this and we notice that x is being changed into half theta. And that's the only difference between these two expressions. So here in place of our x, we're going to write half theta. And we equate it to 3. And our domain is minus 4 pi till 4 pi. Now we'll attempt to solve this equation. First, we're going to equate this to y and write this in terms of y as well, so that our domain and input argument have the same variable. So let y equals half theta plus 1.101. So then theta would be y minus 1.107 upon, in fact, times 2. This is theta. So now I'm going to replace theta with 2 times y minus 1.107. Okay. First, I'm going to divide 3 with all 3 of these to get rid of the 2 in the middle. So I'll get minus 2 pi y minus 1.107. We divide 2 on all the sides, 2 pi. Now I'm going to add 1.107 on all the sides so that I get a y in the middle. So minus 2 pi plus 1.107 gives minus 5.1761, and 2 pi plus 1.107 gives 7.3901. Okay, this is equals to theta. Okay, so now I'm going to rewrite this as under root 5 sine y equals to 3. And now we're ready to solve this within this domain. Okay, let's first find the absolute angle, which will be sine 3 upon under root 5 sine inverse. So shift sine 3 upon under root 5. Right, a very important thing that I missed while drawing comparison between these two was that x is being replaced with half pi. Also notice that this the entire expression is being doubled. So I did not do that. I had to double this as well and then equate it to 3. So then I get 2 under root 5 over here. So there we'll have a 2 square under root 5 in the denominator. So 3 upon 2 under root 5. And now shift sign of this. Okay, that gives me 0.73531. Now we will be sketching. This is the value of y, and sine is positive here, right? Sine y is equals to positive 3 upon 2 under root 5. So that is either in the first quadrant or in the second quadrant. So this is 0.73531, and we have 0.73531. Okay, so now we have to find all the solutions within this given domain. So obviously this is not within the domain. So let's try this one, which will be pi minus 0.7353. That doesn't give me a solution within the domain as well. That gives me 2.4. Now what I'll do, I will make this entire round trip from here till here and check this. This would be 2 pi plus 0.73531, which gives 7.01. That is one solution within the given domain. So we get y equals 7.0184. Okay. I need to look for more solutions. So what if I go in the opposite direction? Okay. So I'll try the negative angle in this direction. This will be pi plus 0.73531. No, that would be negative 3.8. That is in the domain actually. So we're getting, you'll do negative pi plus 0.73531. That gives an answer within the domain y equals negative 3.8769. Okay, now let's check the other value. Let's check this. This will be 2 pi minus that answer. 2 pi minus 0.73531. It's coming out to be 5.54, but it is outside of that is bigger than minus 5.5478. Okay, this is outside of this domain, so we can't choose that. All right, I made a blunder earlier. This is also going to be within the domain, obviously. Y is equals to 0.7353 does lie within this domain. I don't know why did I say it is not earlier. So y equals 0.73531 is also a solution. And so would be this one. So apologies for that big blunder earlier. So pi minus 0.73531, that is 2.4, and that also lies within the domain of y. So 2.40628. Okay, now what we do, we have four values of y within this given domain. We will use this formula and get the four values of theta. So if you replace the y with these values, you're going to get all these angles. Let me try. It's all the four values of theta. So 7.0185 minus 1.107. Answer times 2 gives us 11.8. So 11.8 is the correct answer for theta. The other one I did just check right now. It is minus 9.97. Now I have to check the other two. 0.73531 minus 1.107, and answer into 2 is negative 0.74. And lastly, 2.40628 minus 1.107 times 2 gives us 2.5985, so rounds to 2.60. So these are the four solutions of the given equation.